Alright, so today we're going to talk about two things. Convection and radiation. Sorry for the terribly miserable looking handwriting of mine. So now, convection and radiation come from one thing, which is heat. Alright? Heat is something that happens in every single type of matter. Alright? So, me as a person, I don't necessarily like summer. Right? I think it's hot. I like cold things better. But that doesn't mean I like hot. I don't mean I hate hot. Alright? Hot is everywhere. Right? Even in winter, there is still heat. Alright? So I'll give you an example. Right? Heat is basically what comes out from the molecules inside of a solid or a liquid or a gas vibrates like in place. Alright, so solids obviously have the least heat because usually they're not moving, alright, except for us. We're solid, but we also have liquid inside of us. That's why we have, like a really high base temperature. And inactive objects, they're not moving. So, they don't really have that much heat. Alright, heat is only given to them when we transfer it or it's in a naturally hot room and they transfer it into it. And while heat always goes from a warm place to a cool place, which means that, it will always transfer from something already warm, let's say like a campfire, to you, who is already cool. And eventually, the fire will have its heat, reach equilibrium with you, alright? You'll be as hot as the outer heat is. Obviously not the internal temperature because, you'd be burning to death. So that's heat for you. Now, convection is heat given directly by direct touch, alright? You have to be touching it you can call it convection. So, I'm going to draw a little diagram. Oops. Sorry. So, this is a little stove. There's a little button to turn on. Now, let's see when I turn it on, alright? Let's draw a little... So this is a stove turned on. Now let's place let's say a pot on it. Draw the handle so that way of course we can take it off. Let's fill it to the brim with water. Now heat can transfer directly into the solid, which will heat up the solid. So let's draw a little diagram here for you to really see it. Alright? This is the solid layer of metal, or basically anything that's making up the pot. Alright, these molecules don't move that much. They don't really move that much. But then right under here, there's heat, which causes the particles to move slightly more. Most of the time, it's just the heat going into the matter. Alright, and the inside is water. Well, the water, let's assume it's a cool water. So obviously the heat will go into the cool water. However, it always transfer from the bottom of the pot to the top or the side of the pot. So it'll always go like this. Draw two lines. It will always go like this. It will go outwards, and the colder parts will go up, or maybe up, or occasionally when it's like hot, which is equilibrium, it will go down. And you increase the heat will go up and down until it reaches equilibrium, where the heat from the stove is equal to the heat of the water inside the pot. So that's convection. Now obviously we also have radiation, which I will show you. Don't worry, I will not cut this off. Now radiation is basically convection, but we doesn't need a medium. Medium is like a space where you occupy, right? The medium, which is the floor. Medium is the floor. I'm standing on the floor. And there's air on it. That's also a medium. But radiation doesn't need it, alright? So it's heat that goes through space, alright? It's the only source of, energy that doesn't need a medium to carry it. So, okay, let's say this, alright? Heat going from one end to the other. So that's basically how it works. But in space, there's also something called vacuum. Just like endless, just like a huge amount of absolutely no matter's in there. However, radiation can definitely still go through that and get to where it's supposed to go. Alright, basically where it's pointed. So this doesn't necessarily have to happen in space. It can also happen in, of course, on Earth as well. So the most prominent example that I can give you is related to campfires or maybe like a bonfire. Alright, so this is a terrible fire here. So this is the fire. Obviously, there will be heat when you get near to it. However, heat is also radiating off. Alright, heat's also radiating off from the fire towards you. That's why you don't necessarily have to go too close. You can just get, just a little bit near the fire and you'll still feel warm. So that's radiation right there. So, yeah, that is my explanation of convection and radiation. Thank you for listening to this video, and goodbye. See you next time. And please subscribe.